Thank you, Wang. Distinguished guests, ladies and gentlemen, good morning, good afternoon, and good evening, depending on where you are. A very warm welcome to the 2022 International Workshop on Future Communications. I'm Yeo Kiat Seng, Associate Provost at the Singapore University of Technology and Design, in short, SUTD. To our overseas participants who may not be familiar with SUTD, SUTD is a modern, international, and research-intensive university. It is Singapore's fourth public university, established in 2009 to pioneer interdisciplinary education, research, and design innovation. This workshop focuses on future communications. Future communication is a complex network consisting of a wide variety of products, services, and systems. Coincidentally, SUTD's academic structures are organized in terms of what the world needs, which are products, services, and systems. As the future network will become extremely heterogeneous, it will need a multidisciplinary team to address challenges to wireless connection, spectrum share, as well as data fusion. SUTD interdisciplinary research structure enables it to lead research and discourse on future communications. With speeds of up to 20 gigabit per second and the ability to support up to 1 million devices per square kilometer, 5G, the latest generations of mobile communication technology, may already seem impressive, but 6G is set to take these capabilities even further. For instance, with 5G, it would take about 4 seconds to download a 2-hour movie. However, with 6G, it will only take just 1 second to download 150 hours of Netflix show. With wireless connectivity becoming increasingly common, there will be more applications like virtual, augmented reality, artificial intelligence, and even autonomous vehicles requiring high data rates combined with low latency or delays due to processing time. Accordingly, 6G, with its peak data rate of 1 terabit per second and latencies of 100 microseconds, should be able to smoothly support these use cases. At the same time, individuals and organizations will expect a trustworthy network that can seamlessly and securely deliver data, meaning that further research must focus on building a holistic 6G network security architecture. Since 2020, the standardization of 5G wireless communication networks and the simultaneous deployment across many countries worldwide is underway. Until the start of 5G communication, the network utilization was predominantly for the entertainment video and audio file streaming and buffering applications. One of the core distinctive benefits of 5G communication is the low deterministic latency to assure an end-to-end reliability and accuracy that future application mandate. However, 5G networks consume more energy than 4G networks. This is because off-the-shelf servers are used against the application-specific integrated circuits in a radio access network. In disparity, we must target to deliver the next generation networks that at their introduction time does not surpass the previous generation energy needs. Therefore, the requirements of future networks should not be fulfilled just by merely using 5G. Hence, the focus has started on the research for 6G wireless communication networks. Recently, mathematical computing has developed variations such as cloud computing, fog computing, and edge computing. As these new variations are being evolved, new application scenarios utilizing them are hopeful to resolve some inherent network concerns such as the network flexibility, distributed computing, low latency, and precise time synchronization. These are also some of the limitations of 5G caused by short packets. This restriction from 5G causes degradation of some of the requirements such as high reliability and low latency. Hence, 6G is bound to addressing some challenges application. 6G will likely be an efficient and self-contained ecosystem based on AI, which progressively evolves from being human-centric alone to being human and machine-centric. 6G will also bring a low latency and unrestricted complete wireless connectivity. Hence, enormous efforts are underway to consider beyond state-of-the-art protocols and mechanisms for wireless communication. Thus, the next generation of wireless communication is expected to meet the demands of various challenging use cases that go far beyond distribution of voice, video, and data. I'm therefore delighted to know that this international conference aims to discuss the open problems and present new solutions that address the challenges of future communication systems, such as 6G. Finally, I would like to thank our keynote speakers, conference participants, IEEE Communication Society, and our sponsors for their strong support. My special thanks to the conference organizer, Lin Chiu, and her team for putting together this wonderful program for everyone. Thank you and enjoy the conference.